Right. Turn on the music. Okay. Can you hear me?
Yes.
All right. I'm just gonna let it sit for about like a minute or a minute and a half, and then wait until because I can see when people get on. So far, we only have two. I think it's just ourselves. But I'll wait until we get a few more people. Maybe not a few more people, but like I said, like 6:01-ish. Hello, everybody. Welcome to Workshop Wednesday with Mentor Me Collective. We're so excited to have you join us today. As you're settling in, please drop a fire emoji in the chat to let us know you're here and ready to learn. Drop them in the chat. Drop them in the chat. Okay, I see you. I see you. Awesome. Bay Area. Okay, awesome. Great to have you guys in today joining us. Super excited for what we have tonight. For those of you who are new to Mentor Me Collective, we're a community dedicated to empowering individuals in their tech careers through education, mentorship, and community. Make sure to hit the follow button if you're joining us from LinkedIn. If you're rocking with us on YouTube, go ahead and hit subscribe. You can also like this video too. My name is Lauren, and I'm thrilled to be your host on the workshop today. This March, we're celebrating Women's History Month and International Women's Day with a theme that truly resonates: pioneer, progress, redefine possible. We're highlighting incredible technologists who are making a real impact in the world. And today we have a fantastic session planned for you. We'll be diving deep into the fundamentals of working with large language models, or LLMs, and how to integrate them into AI-powered projects. You'll learn essential skills, techniques like prompt engineering, output refinement, and validation, all designed to help you generate valuable, consistent content. By the end of this workshop, you'll be equipped to design robust AI-driven features leveraging LLMs to build smarter solutions for a wide range of integrations. Now, let me introduce our incredible speaker, Alyce B. Alyce is a seasoned software engineer with a rich background in developing full stack mobile and web applications and integrating AI into products. Just like Mentor Me Collective aims to empower individuals through education, mentorship, and community, Alyce embodies these values in her work and career. She brings diverse experience from fast-paced environments at startups and larger companies like Boston Dynamics, focusing on translating innovative ideas into impactful, user-centric solutions. She is a software engineer at SpoilSaver, Ringside Pro, specializing in full stack SaaS development for mobile and web. Welcome to the stage, Alyce.
Hi, everyone. It's great to be here.
Alyce, before we dive into the presentation, let's break the ice with a fun question. If you could describe yourself as a superhero, who would it be and why?
If I'm actually going to change that question up a little bit and go with my favorite superpower. If I could have any superpower, I would probably choose teleportation so that I can pop up at any event that I needed to be at and just start thriving.
I love that. Oh, that's a really cool answer. Superpowers are amazing. I'm all for it. I do want to now turn this question more towards the chat now. Let me hear from you people in the chat. What's your favorite dessert? Make sure to share it in the chat or even use an emoji. All right, let's get started. Please share your screens and slides. If you could pull those up, I'll pull them up for you. Over to you, Alyce.
Welcome to this session on techniques for building AI-powered software systems. My name is Alyce B, and I am a software engineer who has had 5 years of experience in different fields of engineering, from robotics to solar and many more. Currently, I'm focused on developing mobile and web applications as a full stack developer. And I've actually created my own app with my co-founder, Sarah Johnson. It's called SpoilSaver. And this is what got me interested in the topic of integrating LLMs into software systems. We use AI to give you a kitchen assistant that allows you to receive notifications as well as storage tips to help your food last longer and save you money. I'm also happy to announce that I am a Women Techmaker ambassador, which is actually one of the reasons why I got involved in this community. Just a little thing before we continue, I wanted to let you know that if you have any questions, please drop them in the chat and I'll get to them at the end so that all your questions can get answered. Today, we will be diving into LLMs by getting to know real-world examples of generic and specialized models, understanding how they generate output, designing a robust generic model solution, and diving deeper into pre- and post-processing techniques, followed by a live demo of the concepts in action. Today, we will be focusing on the integration of generic large language models, where we aim at providing value in small-scale applications using LLM APIs. Depending on your use case of your application, it's important to have good understanding of the LLM landscape when choosing an option that will provide the most value for your app. The two major model types are generic and specialized models. A generic LLM is a broad, pre-trained model capable of handling a wide range of tasks, but lacks the deep expertise and vocabulary for specialized areas. A few examples of generic models are content creation apps for blog writing, copywriting, and essay or research paper summarization, and natural language processing search integration in real estate apps, for example, which allow you to look up things like, I'm looking for a single family home in a quiet beach neighborhood, versus needing to try to figure out what filters are going to give you the most accurate list of options based on what you're looking for. Chatbots also use this type of generic model, which is why you can ask it a really wide range of different questions about different topics. SpoilSaver is actually also built using an LLM API. It provides estimated expiration dates for a wide range of food items as well as leftovers. And it also gives you storage tips based on things that it was trained on. And those help you store food for longer. All of these leverage generic models to provide value based on specific audience, whereas a more specialized model is one trained to have a deeper understanding of a particular domain, such as medicine, finance, or law. If you're looking into leveraging a more specialized LLM for your application, it's a good idea to take a look into fine-tuning, which gives the LLM a deeper understanding of vocabulary in a specific area, and retrieval augmented generation, or RAG architecture, which gives it access to local up-to-date data for its responses. Some examples of this include fraud detection, which is used in financial institutions to catch transactional anomalies and lets them know that something is going wrong in the system that may indicate fraudulent activity. Medical diagnosis assistance, and legal document analysis tools, all of which are trained on proprietary data sets to most accurately serve their specific use case. With these different types of models in mind, let's dive into understanding how the LLMs generate output. The first step once an LLM receives a prompt is to begin tokenizing, which is the process of converting the words it receives into a prompt, and then, it takes the words from the prompt and starts breaking them down into tokens. A token is a collection of characters that have a semantic meaning for the model. To get a rough idea, a sentence with about 10 words might equate to about 15 or 20 tokens. So as you can see here in this picture, tomato is, or I guess it says tomatoes, is actually broken down into quite a few different tokens. And those all help provide context for what that specific word means in relation to the others. This is important because the generation process continues using a transformer architecture designed to understand the context of the tokens in relation to every other word. It doesn't read a sentence as we would, but it rather takes a more holistic approach to contextually understanding each word, as well as its significance in comparison to the context of the other words. It does this using a combination of self-attention and autoregression. Self-attention helps a model determine how words in a sentence or paragraph relate to each other, no matter how far they are apart in terms of where they are in the prompt or in its own training set. Assigning weight to each word based on the LLM's trained vocabulary. Instead of just looking at words one by one, the model compares each word to the others and decides which ones are most important when trying to understand its meaning. In this example, we can take a look at how a model chooses to focus on different words based on the gender shown on the left of each row and the topic shown at the top of each column. We can see that self-attention helps focus the model on different gender-specific terms, names, and occupations by switching she with he in the generation sequence. We can see that here, for example, if we're looking at occupation, we can see that it says she, which focuses on the fact that nurse is probably a more relevant thing to focus on. Whereas if it's he, then it focuses on different aspects of the prompt that was sent to it. This allows the model to focus on key parts of a sentence, helping it generate more accurate and coherent text. While self-attention is a core part of how the transformer architecture works to weigh each word's importance, autoregression works alongside it to produce text in a logical step-by-step generation process, ensuring that each token depends on prior outputs rather than being generated all at once. In this example, the prompt starts out with a given prompt. It predicts the next token based on the previous ones. And once selected, the newly generated token, it appended that token to the input, and the process repeats until the output sequence is complete. By combining tokenization, self-attention, and auto-regression, the LLM's transformer architecture generates fluent and coherent text while respecting contextual dependencies to create output that is human-like. In this picture, you can see that it first generates today, and then it brings that information back into the model to help generate the future tokens that it's then going to parse together at the end to give us a coherent message. With that foundation, let's explore building a robust system. With the goal of ensuring a higher level of reliability in our application, we can implement pre- and post-processing techniques alongside tweaking parameters that influence the LLM black box. To improve reliability and consistency in our application, we need to go beyond just connecting an LLM to our application. We need to engineer around it. That means leveraging pre- and post-processing techniques and refining the LLM's parameters. As you can see here, this is an overview of a robust LLM system that directly impacts performance by wrapping the LLM's integration in pre- and post-processing techniques. Where we first put a focus on prompt engineering to craft that efficient request. Then we can tweak a few things that go into the generation process of the LLM itself. And following that, we can do different structuring and validation techniques to make sure that it is exactly what we're looking to accept into our app. And we help reduce a lot of failures that might occur since this LLM portion is this black box that we don't really have too much control over. When engineering your prompt to help refine the generated LLM output, there are 4 different considerations we can implement. First, giving the AI a persona helps it think like a human with a specific role, stay consistent in its tone, and target the relevant data it was trained on regarding that specific realm of information. So in this example, we're wanting it to act as a travel assistant. Next, incorporating user inputs and variables helps customize what context the LLM has to refer to. This helps cater the output specifically to that request rather than being more generic, unless that's what you're looking for. Oops. Third, we ask for a data structure and define the desired type that we're looking for to most effectively leverage it in your app. So say I am asking for quite a few different things from the LLM itself, and I want to receive that information back so that it's organized and I'm actually able to use it at the end. If I'm expecting a key value pair, then that's what I want it to return. Lastly, we want to make sure that we provide an output example. Without adding real values, you can give an example of how you'd like it to look. Using a template style example without specifics helps to guide the generated output. The reason why I mentioned not putting specifics in there and using it more like a template is because I've noticed when I have been playing around with the integration of LLMs, if you create a structure that is extremely structured, like it has a bunch of numbers and different items in it, sometimes it latches onto those specifics and consistently uses that to generate an output output that you're expecting, even though that might not be what you want. So back to me mentioning that I was tweaking around with it a lot to figure all this out. Don't forget to do that. As you're integrating it, make sure that you take a good amount of time to make sure that you're implementing it and that it's giving you back what you're actually expected. The more concise you keep the prompt, the less context is needed, making the LLM implementation more efficient and less costly as a service that's integrated into your product. So you do have to pay. It depends, kind of varies based on the LLM that you're actually implementing. But just to keep that in mind, keeping things short is usually a lot better. One tip is as you're developing the prompt, AI can actually help you refine and clarify what it needs to trigger producing the correct output. So sometimes if I'm crafting a prompt, I follow these certain parameters that I want to include, like the persona, variables, data structures, and examples. But I might be able to put that into an LLM to say, please refine this so that it does make it shorter, it makes it more concise and more to the point. Next, let's take a look into refining the LLM. With the understanding that integrating an LLM component into our applications system is essentially a black box, API providers do give developers some parameters that allow us to tweak the randomness and diversity in token selection. Together, the refinement methods are called the sampling strategy. These things help us tweak what is coming out of the LLM and also help speed it up a little bit. The sampling strategy can significantly alter the output by controlling how the model selects words during generation. The temperature adjusts randomness. Lower values make outputs more deterministic, while higher values increase creativity and variability. If you're imagining creating an app that is making a travel itinerary for your users, temperature would adjust how the app generates the itinerary based on your preferences. A low temperature, example 0.2, will generate a more predictable and structured itinerary focusing on well-known popular spots like museums, restaurants, and landmarks, whereas a high temperature output closer to 1 or higher will look for more creative and suggest unique off the beaten path experiences like hidden cafes, quirky little restaurants and local spots, or less crowded parks. Coming to number 2, top K sampling limits token selection to the number of most probable choices, reducing the chance of low probability or irrelevant words. Here we use top 3 to ensure that only the 3 most likely words are considered. The third section here goes over top P or nucleus sampling, which dynamically adjusts the selection pool by choosing from the smallest set of tokens whose cumulative probability exceeds a threshold. Here we chose 70%, which ensures only the most contextually relevant words are considered, regardless of a fixed K value. Although top K and top P work independently, they can also be combined, as seen in this example, to refine the output by using top K to limit the pool of tokens to the most likely choices, and then applying top P to further filter those tokens based on the cumulative probability. You get a balance of diversity and relevance. This combination ensures that the model generates more coherent and contextually appropriate text while still allowing for creative variation. Now that we understand how to refine the generation component, let's look into post-processing techniques. Although we ask the LLM to structure the output in our engineered prompt, sometimes things go wrong, and data is not always returned as expected. To further safeguard the data that you're handling within your app and make your LLM's integration more robust, we can put checks in place to ensure the data is structured as expected. After the model generates the output, you can apply rules to check and convert unstructured responses into structured formats, such as parsing plain text into JSON or CSV. In the upcoming live demo, we'll take a look at how requesting a key value pair object will allow us to format our response in a clear list for the user. Not only is this useful for us to process the response, but it also allows us to validate certain keys based on what we expect their values to contain. The post-processing validation step reduces the need for manual intervention, saving time and effort while ensuring consistency in validating procedures. For rule-based validation, incoming data is checked against predefined criteria to ensure compliance. This helps catch errors early and enforces structured input, reducing the likelihood of invalid or misleading outputs from the LLM. In this example, we can imagine that you're asking for a date. Rule-based validation would check that the date returned follows a specific set of rules, such as the correct date formatting. For example, we want it to be in month, day, year format. And if that's not true, then it returns with an error. Or asking if any of the values are null. You can do a quick check for that and then also return the exact one that was missing in our next step. Let's see. Another key validation we can use to drastically reduce potential errors is error feedback looping. This is my favorite part. Error feedback looping can be leveraged throughout the different validation steps to take action on specific errors returned that can be fed back into the LLM in order to request a more informed response. By providing errors in a feedback loop, we have a much higher probability that the user will not be met with a hallucinative output created by the LLM or null data. Here, we can see what the system looks like. Imagine one of the previous rules producing an error that can then be fed back into the system as an updated prompt and then given back to AI with that smarter understanding of what it needs to return to you. So for example, we send our prompt in to begin with. It's just what we created earlier. And it gave us something that didn't work. Then it goes through our validation process and says, no, this is not validated. We're not accepting it. You need to send it back and get a new output. So we send that error that was produced in the previous steps and we attach it or append it to our prompt as an updated version. And then we send that back into the AI. It's good practice to set a limit on the number of retries it's able to do so that we don't run into an infinite loop and potentially start spending money willy-nilly. Just you're going to run into that issue if you don't put some sort of stop to it. So please pay attention to that because I've experienced some issues. Now let's take a look at how this works in action. It's time for our live demo, so I will put the link in the chat so you guys can try it out if you feel like it. And I'm also going to switch my screen over so that we have everything visible here. Oh, I see that there's a question. I can answer it right now as I'm kind of like going over this, and then we can take a look. What level Python does one need to build your own model from scratch? Is intermediate Python enough? Because I tried and things start to go dark with PyTorch and Hugging Face libraries. I'm not 100% sure on those ones specifically, but I would probably recommend to do some research into like projects that have it implemented and kind of reverse engineer it to see what they did to get over those issues. It generally is pretty complicated. One time I built an ML model to identify food items, and the amount of work was not worth it. And I'm really glad that LLMs were able to speed up my development process, because that was a dark hole for me. Let me just share my screen on this new one, and we will take a look. Okay. I think I think that I'm having a little bit of trouble sharing the link. If the host can help me out with that, I would like to post it in the comments so that everyone can have access. In the meantime, this is my demo. I will start by explaining what it's doing, and then we'll take a look at how it's actually working. So this is a packing list generator. It is going to show us what the client sees on this side. And then in the center, this is what's happening in our server. And then on the right side, this is what's happening and being generated from the actual AI API. It kind of works in this, like it goes from user input to engineered prompt. So it parses all of those variables that it collects from the user into the engineered prompt, which then gets passed to the AI model. And then from there, we get a response, which then we validate. And if it is validated, it'll show us a structured output. But if not, it will make a maximum validation attempt 3 times. Like it'll attempt to do that 3 times. And if it does fail is when it's going to show us the error message. So just something to keep in mind is when you're creating an error message for your user, you don't want it to say like, error, something went wrong. You might want to just guide them towards another part of your app, or say, sorry, this is not working right now, or it's coming soon, just to kind of redirect their focus and be a good user experience when you're dealing with real customers. So I'm just going to input going to Los Angeles. That's where I'm from. And we are going to say that we'll be there in June, and that we're going to be there for about 10 days. Oh, can you guys see? Oh, okay, hold on. Let me try sharing it again. Okay, I'm going to stop. I'm going to share a window. Okay, I just reshared my screen. If the host can help me out by showing it. Can you guys see it now?
There might be a lag too with. Okay.
Oh, they can see it. It seems like they can see it.
All right. Bye.
Okay, cool. Thanks. Okay, so I'll just kind of backtrack. This is my packing list generator. I'm just going to reload the screen so that everything goes back to normal. The way that it works is on the left side here, this is what the client sees. The center, this is what's happening on the server. And then also on the right is where the API is being interacted with. So we'll be able to see things dynamically happening when things are loading and when the actual validation step is being triggered as well. So the order of operations here is the user puts in input, it goes to the engineered prompt, parses that data in, and then feeds it into the AI model, which then returns a response, and we either validate it or reject it. And from there, we create a structured output. Okay, so I'm going to go back. We're going to Los Angeles. And we are going to go in July now. We're going to go for 10 days. And the reason why I chose a date that's like way in the future is because I'm asking the assistant to give me weather information as well and make informed choices on that information as my travel assistant. So let's see what it comes up with. Okay. It seems like something might be going wrong. Maybe it's the actual API in the background. So I'm going to go back to my presentation and show you that way because I have, oh, just kidding. It worked. Okay. So as you can see here, it returned a data structure, which is a list of key value pairs. And the way that I did that is the keys are mapped to being these headers that are then shown to the user. And then there's, as a value, an array of different strings that we use as the actual bulleted items. So that's why it's really helpful to have things in a structured way, is because you can predict and also target if you name things specific categories as their keys. So as you can see here, it only took one attempt and it was able to provide this for us. It says Los Angeles weather in July is typically warm and sunny with daytime temperatures ranging from like 70 to 80 degrees Fahrenheit. And it gives us a list of how many items that we should be bringing in terms of clothing, shoes, toiletries, electronics, and more, which is really great. So that is a pretty smooth interaction for me as a user, and we're able to see how the background is working as well, which is kind of fun. I'm going to go back to my presentation and I will show you what it looks like when things go wrong. So previously, are you guys able to see my updated screen? Okay, cool. So this is what happens when it goes wrong. It's going to not match the expected data structure when it's coming out of the AI model. And it's going to feed that error message back into the engineered prompt, which is going to try again. So as you can see here, we're going to Hong Kong. We switched it up a little bit and we're generating. Oh, this is the correct one. Oops. 1 second. Here we go. Okay, we're going to fast forward a little bit. There we go. Once it gets to the parsing and validation step, as you can see, there was that red message that was right in here, and that is the actual error feedback loop happening that is being sent back to the AI model to fix it. And then once it tries 3 times, if it's still unable to get the correct response, it's going to give you an error message. So that's pretty much it. I just wanted to thank everyone for joining today, and I hope you had fun playing around with the live demo. I wanted to thank everyone at Mentor Me Collective, as well as the Women Techmakers program, for hosting this celebration of International Women's Day. And I will hand it off to you.
Thank you so much, Alyce. This was such an amazing and very informative presentation for our workshop Wednesday. I do want to there is a few questions that we had come through, and I'll start with the very first one. I know you did answer one of them, but the first one we do have from Sue. Thank you so much, Sue, for your question. It is, how do you limit bias within self-attention mechanism of large language models?
All right, I'm just going to go back to that slide so that we can make sure that we're having a better understanding of what's going on. So you're talking about self-attention, and the question is asking how we can limit bias. When you're referring to bias, do you have any specific question kind of targeting that a little bit further? I think I'm wondering if you're referring to the he, she. Oh, she to nurse and he to doctor. So it is trained on different LLM models are trained on wide variety of different vocabulary and how things and different tokens relate to others. So right now we're talking about more generic models, and generally when you're talking about nurses or doctors, this is just an example that I found online. I have a list of works cited in the back if you'd like to take a look at this presentation later and kind of dig into those a little bit deeper. But I'm sure that you could not necessarily affect the actual LLM model, since it is more of that black box, but you might be able to use it in your engineered prompt in terms of the parameters that you're looking for. Maybe you want to say, be a little bit more gender neutral. Don't, map, if you're going to be asking about doctors, occupation in this sense, you could say, don't map certain occupations to genders, things like that, just to kind of give it some more understanding of how you expect it and want it to answer. Because we can't really control, unless you are doing one of those more fine-tuned models, we're not able to control how the LLM was trained.
Okay, and we'll move on to the next question.
Okay.
Which is, what level of Python does one need to build your own model from scratch? Did you answer that one?
I think I did answer that one. Again, it is something that's a little bit more complicated. You can't just come up with it off the top of your head. You definitely have to follow a lot of tutorials and things like that. But I highly recommend, if you are actually interested in trying that out, to just start, because once you get to the first roadblock, you'll be able to look up information to then get to the next roadblock, to get to the next and the next. That's just what engineering is. So it's about just tackling the problem head on and trying to figure it out.
All right. And for our last question from the audience, what SaaS development strategies and tools do you recommend for building scalable and maintainable AI-powered products?
I feel like the development strategies in terms of integrating AI into these systems is essentially what we went over. I'm going to go back to my slide if you don't mind sharing it again.
Yeah, no problem.
So these are the different things that come into play, at least what I consider when integrating AI into a system. It's really just making sure that for your specific use case, you are looking at how you want the user to give some information to then be able to integrate into your prompt. As a product, do you want that AI component to generate things that are very structured, or do you want it to be more creative? So that's kind of like up to you as the product developer and your team that you're working with. And then on the back end, that's more of the structuring part and seeing what kind of leeway you're going to allow in your project. So if the AI comes back with a data structure that has a few things that are not even present, so maybe it returns, like if we're talking about my example, it returns nothing for clothes. Like I need clothes to know what I need to pack. That's something that's really key in my system. So I will not allow that to be output to my user. Whereas something that's a little bit more variable, and okay, it's fine if it generates something that's not present for a specific field. Maybe I, as the developer and as the team working to implement the system, will actually like say that that's okay, and we don't actually need to do a validation case for that. So it's really just understanding what kind of product you want to be able to give to your users, and then also working with your internal team to see how all of these different parts will fit together like a puzzle to create a picture that's really robust and smooth in terms of interaction.
Awesome. Thank you. I do have a few more questions. Not from the, I'm pretty much sure those are all the ones from the attendees tonight, but general question, Alyce, for someone completely new to LLMs, what's the single most important thing they should focus on learning first?
I would say if you want to get into understanding LLMs better and just working with them in general, the best thing to do is just start a random small project. Like that project that I just showed you guys for the live demo made me learn so much about how the LLM interacts, what are the different parameters that I can tweak to see a different output. So just playing around with it and actually getting that development experience of how to implement it is really great. Since we were talking about like generic systems and not those specialized ones, I'm actually like, it's pretty quick to be able to implement them. I was able to do like a small project within just a few hours. Like I think that one just took 5 hours. And so yes, granted, I am a little bit more experienced with this. I've been working with LLMs for a few years now, but you just have to start, and then it'll give you more ideas of what you might be able to use it for. So I think that that's a great way to start, just by diving in and trying to create something small if you think it might be useful. I mean, that's also how SpoilSaver began. Just so you know, you guys can check it out on spoilsaver.com. It's also on all of my socials, But essentially, I saw myself throwing away food so often, and I was like, oh my gosh, is this a common problem? Because I wasted $2,600 of food like in a year. That's a month's rent. You know what I mean? So I was thinking of different solutions, and I started out by creating an ML model, which that was insane. For 10 food items, it took like 15,000 pictures. So it was a little bit like out of scope for me and my co-founder to create a whole model to do that. So once LLMs came out, we were like, why don't we just try this to help generate those expiration dates, which we can then use for notifications and storage tips to help people save by, storing them more efficiently. And it worked so well. It turned around our entire idea to product phase extremely quickly. And that's why I'm so passionate about this topic. I really feel like everyone should try implementing a quick project because it can provide a lot of value and give you a lot of amazing ideas, especially as an engineer.
That's so awesome. Hopefully our listeners will take you up on that challenge. And where can they find you at? And will you be sharing another talk soon?
Yes, I will be posting everything on my socials. You can follow me on LinkedIn. My name's Alyce B. And yeah, I have Instagram, LinkedIn, X. You can, on the last slide of this presentation, maybe I should just show it so everyone has the reference. But I also have my email on there. If you have any specific questions or would like to talk further, please feel free to reach out. I'm available. And yeah. Also, I mentioned it earlier, but if you guys are interested in testing out SpoilSaver, we're actually in our beta phase. And you can kind of see how the LLM is integrated into there. I'm not sure that the beta link is live right now because we reached our maximum number of testers. But if you would like to be part of that test group, please send me an email and I'll be happy to add you.
All right. Thank you so much, Alyce, for joining us tonight and sharing your expertise with us today.
Thank you so much for having me.
All righty. And thank you all for joining us. We hope you found this workshop super valuable. We have another exciting workshop coming up next Wednesday, same time, same place. Be sure to subscribe and give this video a thumbs up if you haven't already. And have a great night, everyone.